In this recording, we're going to learn how to make basic graphs of sine and cosine. So if you've never seen these graphs, they're pretty cool looking, much different than parabolas or lines or exponential functions or the other graphs that you know how to make. As it says in the description here, we can make these graphs by considering the quadrantal angles. In other words, the ones that end on the axes, the ones that are multiples of 90 degrees or pi over 2. Now we're typically going to do our graphs in terms of radians. So you can notice here all the x's are in terms of pi. So what I'd like you to do is go back to your unit circle and find the cosine values. Of course, that's the x, right? The cosine values of these particular angles. Fill them all in. And then go back and find the sine values of those angles, the y values at those points, and fill them in. All these numbers should be zeros, ones, or negative ones. Play the recording when you're ready. Okay, so hopefully you worked those out. If not, please do it now. Don't just simply write down what I've got. But if you start at 0, the cosine, the x value is 1. If you go up to pi over 2, the cosine is 0. If you go to pi, it's negative 1. At 3 pi over 2, which is the bottom of the circle, it's down here, the x-coordinate is 0. And then when you get back to 2 pi, it's 1. The opposite is true as you go negatively. Okay, it goes 0, negative 1, 0, 1. Your sine values at the top, at 0, your sine is 0, right? At 0 radians. Then as you work up to pi over 2, it's a 1, then 0, negative 1, and back to 0. Also going to our negative values, negative 1 at the bottom of our unit circle, 0, 1, and then 0. Based on those, we're going to make our sine and cosine graphs. I'm going to try to put those on the same axes with those colors. So the first one I'll graph is the sine function. So at 0 radians, right here at the origin, 0 radians, we have 0 as our value of sine. And then as I move to pi over 2 radians, it's 1, back to 0, down to negative 1, and then back to 0. And it does the same thing as we go to the left. You might say, why didn't you just start at negative 2 pi over here? Well, I just find it more natural to start at 0 because typically we may only start our graph on the y-axis and make just one cycle. Here we're going to make 2 cycles. It's a curve. It's not a straight line. So do your best to make a curve here, and with the tool I'm using, I'm struggling a little bit to make it nice, but do your best, something like that. It should not be a straight line here. It should look like a wave. And if yours is not satisfactory, go ahead and erase it. Redo it. Okay, so we have a nice smooth curve there that makes a sine wave, and then we'll label it. If you have colors, great, use a color, but again, I would like you to use pencil, so it would really just be if you had a colored pencil. Go ahead and make your cosine. Notice how I'm plotting all of these points. Don't just draw a squiggle. Plot those points. You should have all of those points plotted, and then do your best to make the curve in between. You might notice I made some mistakes there plotting those points. I will get rid of those points. There and there. Make sure your 2 functions are labeled. Okay, so at the bottom we have a couple questions about our 2 functions. Okay, it asks us for the domain and range of these functions. Play the recording when you've stated the domain and the range. Okay, so hopefully you said for the domain, it's all real numbers. It does not really end here at negative 2 pi just because I stopped at negative 2 pi. I could have kept going around the circle, right? But our range is bound. It never goes above 1 or below negative 1, just on the, like on the circle, right? The y or the x values, and so that's going to be with brackets. This is interval notation. I'd like you also to write it in set builder notation, x such that we are between negative infinity and positive infinity. And at this point in your math life, I would expect that you are fluent in both notations, both the interval notation with the brackets and parentheses, as well as set builder notation. On a test, on a Regents, you could express your sets in either form, but I would need you to be able to recognize either one if it were presented on a multiple choice. Okay, and finally here, it asks for the horizontal distance where the sine and cosine repeat its basic pattern. So I guess one way to think about it is, okay, I'm starting here at negative 2 pi. I go up to 1, back to 0. But I haven't really completed the whole pattern, right? Because I still have to go down. Go down, back up, and then it starts back at 0 going up again. So it took 2 pi for it to complete this pattern. Makes a whole lot of sense, right? Because 2 pi consists of a whole trip around the circle. So 2 pi is the period for a sine or a cosine, and both of these are called sinusoids. Okay, fancy mathy name. Sinusoids, cool name. Back in Algebra 2, you did a lot of work with transformations of functions. Okay, we're going to do a basic transformation today. We're going to put an a value, a leading coefficient, in front of a sine and a cosine function. Well, just think about what effect that might have on any graph, whether it was y equals a times b to the x, should be up there, or maybe y equals a x squared, what that would do. And hopefully you realize that's going to vertically stretch our function. Now you couldn't see it so well with the parabola. It almost looked like it got skinnier, but really what it did is it got stretched out in a vertical direction. So this says go ahead and put this into your calculator. Hey, we're better than that. We don't need that. We're going to look at this function here. We've got a graph of the cosine function, the basic cosine, and it's got a 3 in front. In other words, all the y values, because it says y equals, are being multiplied by 3. Well, that's easy to do because these are either 1s or 0s or negative 1s. So even without your calculator, let's just play along here. If I multiply this point by 3, it becomes 3, right? If I multiply this point by 3, nothing happens, right? It's still at 0. If I take this point and multiply it by 3, it becomes negative 3. So you can kind of see what's going on here. I'm plotting one whole cycle of 3 cosine x. So it got stretched out in a vertical direction. And just do your best to make a curve. And then label. I'm going to use another color for clarity here. Let's do y equals negative 4 cosine x. Well, you remember what happens to a function if it's negated. What if I have a negative 4 in front of an x squared? Well, you know that would make an upside down parabola, right? It reflects the y values in the x-axis. So if I have a point here and I reflect it over the x-axis, it becomes negative. But if I multiply this 1 not only by a negative but by a negative 4, now it's down here at negative 4. Zeros are still zeros. When I multiply negative 4 by negative 1, it becomes a positive 4. So this point is way up here. And the pattern continues. Of course, you could check this on your calculator. You could get in radian mode and graph this. So hopefully you're taking time to pause your recording and make clean graphs. You're not rushing it and making sloppy graphs just to get done with the video. I'm not going to have you graph this one or this one just because I feel like our axes is already getting pretty cluttered. It's getting hard to see the graphs. These are going to be 2 additional graphs, but I think you can use your imagination. Certainly could use your graphing calculator, that Desmos program, to see what these graphs would look like. Okay, so let's scroll down a little bit and get a key vocab word here. It says the coefficient controls the height that the cosine rises above and falls, rises and falls above the x-axis. Its absolute value, meaning it doesn't matter if it's positive or negative, is given this name amplitude. So in terms of sound waves, it indicates the volume of the sound. And you might have heard of like AM radio, that's amplitude modulation, you know. And so this 3 means that the amplitude of the graph is 3. It goes 3 above and 3 below the midline. Whereas this 4, the absolute value of this coefficient, means it goes 4 below and 4 above the midline, which in this case is the x-axis. What I'd like you to do in terms of practice is I'd like you to work out this one and this one. Actually, I changed my mind. Let's have you do this one. So positive 2 sine x and negative 1/2 sine x. I'd like you to put those both on the same axes and then play the recording to check your answers. Okay, so if we did both of those, we'll go through this quickly. So there you have those 2 transformations of the sine wave. And before we sign off, I want to show you real quick on a graphing calculator how to graph the 2 functions. So if you have a graphing calculator, you're going to go to your y equals, clear out whatever's there. You could do sine of x. Okay, so I'm going to do sine of x in blue, and then below that I'm going to do, let's say, negative 2. Well, we'll put them both on. We'll do 2 sine x. And then we'll do, in black, we will do negative 1/2. Okay, so this should replicate what we just did on our paper. So there's a special zoom for trig, and it's called Z-trig. It's choice 7. That's going to give you a nice graphing window. So there goes our regular function, our 2 sine x, and then finally our negative 1/2 sine x. Thanks for watching.